Hello everyone, thank you for joining me today in this session. So today in this session we're going to begin this project 0x06 C more pointers, arrays and strings. So this is just a bit advanced of the previous project we solved, which is 0x05 C pointers, arrays and strings, but the idea is the same. If you understood what pointers, arrays and strings are, then you still solve the same problems on this particular project. Okay. Alright, so before I begin, as you can see here, we are supposed to go through to this repository, right? So I'm already inside that repository. Yeah, so also you need to create this directory. I've already created the directory here, and don't forget, when you create the directory, you need to add your readme, which I did also. So let me also give you an overview of my main.h. Okay, so this is my main.h here. So all the prototypes for this particular project are stored inside this main.h, so that I will not be opening the main.h every time. Okay, also as you can see here, I have the prototype for my underscore putka, right? So you need to create your own underscore putka as well, because you are going to be using it here. Okay, not necessary, but if the need arises, you are going to use it. Okay, so let me give you an overview of the function underscore putka. So as you can see, this is the function. So I already have it written in this file. This is the file underscore putka.c. I'm sure this is not something new. Alright, so let's begin solving examples. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to b12learn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX complete C programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, small nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor. Because I've already registered, that's why you're seeing you are not registered as an instructor. In your own case, you will see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. So this first task here says we should write a function that concatenates two strings. So the function should concatenate two strings. So what does concatenation means in the first place? Let me give you an example. Concatenation simply means, let's say you have your name is, let's say, Sam, right? And your surname is John. So if you're asked to concatenate these two strings, what are you supposed to get? At the end, you are supposed to get what? Sam John here. That's your full name. That's simply concatenation. So I've concatenated John with what? With Sam. This is simply what concatenation is. So as you can see, this will serve as our S1 and this will serve as our S2. Do you get it? Or let me say, this will serve as our source and this will serve as our dest. So it means we are concatenating everything from John, we are taking it to Sam, so that they will be what? They will be stored in the same place. Do you get it? So that's what this question is asking us to do. Okay, so let's see how to overcome this and how we can write the solution to this problem here. So this is the prototype. The function appends. So just look at this. The function appends source string to the dest string. So whatever is passed as this source string, it is going to be appended to the dest string. overwriting the terminating null byte at the end of dest and then adds a terminating null byte. So return a pointer to the resulting string, and the standard library function strcat performs the same operation as the function we are supposed to write here. So this is just telling you that whatever you pass as the second parameter will be appended to what is what passed in the first parameter. Do you get it? So let me give you the same example I did initially. We have Sam, right? Sam here is our, let me do something like this. We have our dest, right? Let me just say my dest is what is Sam, right? My dest is Sam, and then my source is what, let's say, is John, right? So I'm supposed to what? I'm supposed to loop over all of this, right? Source, all of the source. For each iteration of source, I will copy the content into what? Into Sam. Do you get it? I'll copy the content into Sam. So Sam is stored in the memory in this format. I'm coming. Let me delete this. This is how Sam is stored in the memory, right? S, A, M, and what? The terminating number, because this is a string. So we have John here also. John is stored like this in the memory, right, with the terminating number. So I'm appending John to Sam. So this index 0, index 1, index 2, index 3, index 4. So this index 0 of the source here, right, this is where I want to start appending from. I need to start from the first character, second character, to up to the end, right? So this first index 0 should be what? Should be appended to the terminating number. Should replace the terminating number, sorry, of the dest. Do you get it? It should replace the terminating number, because we are adding another set of string here, right? So we cannot leave a terminating null byte while there are other strings that will come. So that's why we need to overwrite this terminating null byte. So our J will be replaced here, will be placed here. Do you get it? Then the next thing we have is our what? O. The next thing we have is our H. The next thing we have is our N. So at the end of this, we can add the terminating null byte. So as you can see now, we have what? A concatenated string, Sam John. So I'm just giving you an insight on how we can approach this problem. So by looking at this, how can you know which index you need to start appending to your dest to, right? So now we have, this is what we have, something like this, right? The terminating number. So it means that I need to know the length of dest. This is index 0, right? Index 1, index 2, index 3. So I need to know the length of dest before I'll be able to know from which index I will start appending the content of source, right? So as you can see here, I'm beginning my appending from where? Index 3 of dest, right? I need to append to index 3 of dest. So it means that I cannot know which index I need to start appending to of dest until I know the exact length of dest. So here I know the length of dest is what? Is 3. 1, 2, 3, the number of characters, right? SAM, we have 3, isn't it? So it means that now I can begin my append from index 3, because index 3 is holding the terminating number. So I can begin my append from index 3. If the length is 5, let's say, assuming we have, let me do something like this. Assuming we have, let's say, let me just say Samuel, like this. So if we have something like this, how many characters? 1, 2, 3, 4, 5, 6, 7, 6, sorry, excluding terminating number, right? So 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 6 characters here. So now the length of this string is 6. So it means I can start appending from where? Index 6, because index 6 here is holding what? It's holding the terminating number. So I cannot know the index in which I need to start appending to until I know the length of my destination string. Okay, so if I know the length of the destination string, I can loop over my source and then start appending to what? To the index, which is equals to the length of the destination string. Do you get it? So let's see how we can solve this problem here. So let's open the file. vi paste. So I already have the Betty documentation here, so that we'll not be wasting time on writing Betty. This is the documentation, okay? All right, so the first thing we need to do, like I said, we need to know the length of the destination string, and I also need to find the length of the source string as well. So let me declare the variables that I'm going to use to hold the length of the dest string and also the source string. So let me say int dest len. I will initialize it to 0. It is going to hold the length of the destination string. So int, let me call it source len here, is equals to 0. It is going to hold the length of the source string. So I will declare I here. I is going to hold, I'm going to use I for my looping. And here we also need to find the length of the source string, and I'm going to show you why. Okay, so now let's begin our looping. I need to loop over what? The entire dest string and also the source string, so that I will be able to find the length, right? So I is equals to 0. This is not something new. So dest index I, we are looping over all of the string, right? Dest index I not equals to the terminating null byte, then I plus plus. All right, so we are looping over the entire characters of dest. So I'll just say dest len plus plus. So now this loop here is going to keep track of what? The number of characters. It's going to give us the number of characters that are stored in len. So the next loop is for the the source string. So for I equals to 0 as well. So in this case, I'll use src index I. As far as it is not equals to the terminating null byte, then I plus plus. So here, what can we do? I'll just say src len plus plus. So now we have these two variables here, the dest len and the source len. This will give us the exact characters, the exact number of characters passed as the destination character and also the source character, right? So the next thing we need to do is, don't forget here, we need to loop over, we are only looping over source to do the appending, right? We are only looping over source, right? We are only looping over J, O, H, N. Consider this example. J will be appended to the last index of this. O will be appended to the last index of this. That's how we keep going, right? So I will now create a loop to iterate over my source here. So I'm beginning from the first index of source, right? Because I'm concatenating everything, right? So what should be the condition here? The condition is simply this. You know that we've already found the length of source, right? So it means that we cannot loop and exceed the length of source, isn't it? We cannot loop and exceed the length of source. So I need to say I less than what? Source len here, right? But when you look at this, we know that the length of source here is not going to count including the terminating null byte, right? And when you look at this here, it says we overwrite the terminating null byte at the end of this and adds a terminating null byte. So at the end, we need to add a terminating null byte. That is after the concatenation. That is this last terminating null byte here. Do you get it? So after all the concatenation, you need to add what? A terminating null byte at the end. Do you get it? That is after concatenating John to Samuel, add a terminating null byte. But during the concatenation, you need to get rid of this one here, that of the destination string. Do you get it? Because terminating null byte is only appearing once in a string. That is at the end of the string. Okay, so it means that if I do something like this, there is no provision for the terminating null byte, because we know that definitely source len is not going to count including terminating null byte. So if I do something like this, less than or equals to, so it will provide a position, or it will provide a position to store the terminating null byte. Okay, so here I can just say I plus plus. So now this is how this for loop is going to look like. Okay, I don't know if you understand this. Just that I'm starting my iteration from index 0 of source, and also I has to be less than or equals to the length of source, and I've explained why I use equal to. Assuming we are not going to provide a position for the terminating null byte, then we cannot use equal to. Okay, we can just use less than source length, so that we don't want it to exceed the length of the source. But because we are providing a space for what? For the terminating null byte, that's why I need to add an extra space, which is why I use the equality sign. So it's going to include from 0 to whatever the length of source is. Do you get it? So now how do we do the concatenation? When you look at this here, I'm concatenating whatever is in index 0 of source, right? So I will do like this. That is for the first iteration. So I will say source index I. So what does this mean? This means that whatever the value of I is, check what is in that index. In the first case, I is 0, so it will check index 0 of source, right? It will check index 0 of source. So where are we concatenating, or where are we appending the index 0 of source? We are appending it to where? We are appending it to dest, isn't it? So I'll just say dest So what index of dest are we appending index 0 to? So when you look at this, the dest here, we are appending index 0 of dest, of source, to which index of dest? Just look at this, index 6 here, because that is what? The terminating null byte. Let me just delete this. Let me just remove from this part. Let me just do like this, index 3. Right? So when you look at this, we are concatenating from index 3. So we want J here to replace index 3, which is terminating null byte. Isn't it? That's what we want to do. So SAM here is the dest. So we are appending to the last index here. And what is the last index? Index 3. So how will we know the last index of what? Of dest to append to? That is the reason why we find the length of the destination string. Because when you look at this, the length of the destination string is 3. So it means the last character, the last index that has the terminating null byte is 3. If the length of the destination string is 10, it means the last, the index that holds the terminating null byte is index 10. Do you get it? So that's the reason why we decided to find the length of the dest string. So here I will just say dest length. So it means that it will start appending from whatever the length of dest is, which is this index, the last index, which holds the terminating null byte. Okay. So but when you look at this, this is only going to work for the first iteration. So if the value of I increments to 1 now, what will happen? If I increments to 1, so it will copy SR index 1, which is this O, right? So where will it take you to? It will take you to this here, dest length. It's still dest length. So it will still override the same last element here of the destination string. So in the first iteration, J is now stored in this position, right? So now we have J. So in the second iteration, this J now will be replaced with O, because you are not changing the index to store the what? The element. Do you get it? So all I need to do here is I need to say plus I. So it means that as the value of I is changing, the value of the destination string is changing as well. So considering the first iteration, the second iteration where I is equals to 1. So what will happen is this. It will copy index 1 of SRC, right? And it will take it to what? What is the length of this string? The length of this string is 3, right? 1, 2, 3. So 3 plus 1 will give us what? Will give us 4. So it will just append it here, and it will be what? 4 here. So O will now be stored here. Do you get it? So here we have what? Here we have J, right? So here we are going to have what? We are going to have O. So as you can see, we are appending. So if it moves to the next iteration now, if I moves to 2 here, so what is in index 2 of source? Index 2 of source, we have H, right? So index 2 of source, we have H. So this will target the index 2. So dest length plus I is what? Don't forget, I is now 2 in this iteration. So dest length is what? Is 3. 3 plus 2 is 5, right? So it will now move to index 5. This is what? 4, and this is what? Index 5. So in index 5, it will store the value of H. That's how it will keep doing it until it reaches the end of this string here, which is what? The terminating null byte. So it is going to copy including the terminating null byte, because we've made a provision for that space already here. Okay, I believe this is clear. So at the end, what should we do? We are asked to return what? A pointer to the resulting string dest, right? So we are returning a pointer to the dest, which is holding the what? The result of the concatenated string. So here I will just say return, and then I will pass in what? Dest here. That's all. So let's run Betty here. 0. Okay, trailing white space in line 20. So let's see. Set number line 20. Okay, yeah. Yeah, I think it's okay now. So let's run Betty again. Yeah, so let's copy this, the test file, and let's see if we will get the exact output. So vi 0 main.c, paste. So hash include. All right, so let's compile this. Compile, paste. Yeah, so let's run the compiled file. All right, so as you can see, let me just clear and show you again. So here, as you can see, we are getting the exact output here. And this is what happened. When you look at this, for the first iteration, for the first call to the function, S1 and S2 was passed to the function, and this is S1, it is hello, and S2 is world. Isn't it? S1 is hello and S2 is world here. So that's why we are getting hello world printed. This is the first call to the function, right? This is the first call to the function. So S1 is printed, and then when you look at this, S1 was printed, right? Look at this, S2 was printed. So that's why we got hello and world. These are what? S1 and S2. So when the function is called here, it passes, it takes in S1 and S2 as parameters, which is hello and world. So we are supposed to get what? Hello world. That's the concatenated string. That's why we are having this. Do you get it? That's the reason why we are having this. So this is just how to concatenate string. Okay, you just need some trick at times. You just need to think for you to be able to develop the pattern on how you can do all these things. Okay, so don't forget to add, commit, and push to your GitHub repository, and then you can run your checks. So this task here says we should write a function that concatenates two strings. This is similar to the previous task, but let's move ahead and let's see what differentiates these two tasks. So it says the strncat function is similar to strcat here, as you can see, except that it will use at most n byte from source, and src does not need to be null terminated if it contains n or more byte. Return a pointer to the resulting string test. So what this is saying is that in this case, in the previous example, that's task 0, we concatenated everything from source to dest, right? So in this case, we are not concatenating everything from source to dest. We are concatenating n byte. As you can see, there's an additional parameter here, n. So it means that if the value 5 is passed to this as the value of n, it means that it is only going to copy n byte of source to what? To dest. So it is going to copy just 5 characters. If assuming the value of n is 5, so it's going to copy only 5 characters of source to dest. The reason why we said a 5 byte is because characters are what? 1 byte each. So if you pass 5 here, it's going to copy 5 byte here, which is 5 characters from source, and it will concatenate it to dest. Do you get it? So here you have the option to choose the number of characters you want to concatenate. Do you get it? So how do we do this? Let's open the file. As far as you understood the previous task, I'm sure you don't have problem with this one as well. So here we have this. This is the the Betty documentation. I've already documented Betty to avoid wasting time. So what is the first thing we need to do? The first thing we need to do is we need to know the length of what? Of our dest. Isn't it? Just like the way I said in the previous example. We need to find the length of our dest. So if we have Sam here, right? If we have Sam like this, right, ending with a terminating null byte, and we have John also ending with a terminating null byte. If our value of n is 2, for instance, so we are only going to copy what? J and O, because we are only copying 2 byte, right? So we are only going to copy J and append it to this destination here. So J will be stored here. So, and in the next append, we have our what? Our 0. So as you can see, we are only appending how many? 2 byte, right? We are only appending 2 byte, or let me say 2 characters. That's just what the question should do. We are not appending everything, okay? From what? From the source to dest. This is the dest, and this is the source. So we are not appending everything from source to dest. We are appending n bytes, okay? So the first thing we need to do, like I said, we need to find the length, right? Because if we don't know the length of this, we cannot know the index in which we need to begin our appending from. This is index 0, right? Index 1, index 2, and then this is index 3, index 4, right? So we need to know the index. Please, if you've not watched the previous video on the task 0, please go back and watch the video. You understand what I mean here, okay? So now we need to find the length. So I need to say int. Let me call what should I call the variable? Let me just call it index, for instance, or let me call it length, right? So here I want to store the length of the destination string. So in this case, if you look at this, we are not given any restriction not to use the standard library. So I can use the standard library. So I can use strlen. So this is a function that is used to find the length of a string. So instead of us to write our own function to find the length of a string, I can simply call that of the standard library. Okay, it will still work. Believe me, I've tested this and the checker has passed the checks. Okay, so don't worry, it will still work. Since we are not restricted not to use the standard library, so we can use it. Okay, so I'm finding the length of dest, so I need to pass this. So now the length of dest will be stored inside this variable length, right? So the next thing we need to do is I need to declare a variable I, which I'm going to use for my looping, because I need to loop over what? Over the source string. So here, what I need to do is I will now say for I, I'm beginning from where? From 0, right? From index 0. So what should be my condition? My condition is I don't want to exceed n. Isn't it? I don't want, if n is 2, I don't need to exceed 2. If you count 0, 1, that's why we get to, right? So I will say I less than n. So also when you look at this here, we have two conditions to check for this, right? So we need to make sure that our I did not exceed the number of bytes in which we want to concatenate, right? Which is n. And also, since we are looping over SRC, we need to ensure that we have not reached the what? The terminating null byte, right? So I need to add another condition here. I'll just say and also what? And also SRC here. So I say asterisk SRC. What does this mean? This means that whatever, don't forget this is the referencing, okay? I'm dereferencing the exact value at SRC at that point. If it is not equals to, sorry, I'll say it is, if it is not equals to the terminating null byte, then I will say I plus plus. I plus plus. So this is just me targeting what? Making sure that I did not exceed n, and also the element or the character as SRC at SRC, that is these characters here, J, O, H, and N, are not what? Are not the it's not the terminating null byte. Okay, so if this condition is true, so we need to do this. What do we need to do inside our loop? I will now need to what? Do the concatenation. Sorry, let me tab this. So now the next is for us to do the concatenation. Maybe you are confused about this asterisk SRC. This is the referencing. For the first call to asterisk SRC, it will check what? The first byte here, which is G. Okay, it will check the first byte, which is G. So at this, inside this loop, I need to say SRC plus plus. I think now you begin to understand why I used SRC, right? So now after checking for this condition, if it is not equals to this, it will execute whatever we are going to write here, right? Which is what? This is where we do the concatenation. So we are concatenating to the dest string, right? So we just say dest, and what should be the index? Don't forget, we have the length of our dest stored inside len, right? So I just say len and what? Plus I here. So it's equals to what? SRC index I. Please, I've explained this in the previous video, which is task 0. Okay, so please refer to task 0 if you don't understand what I'm doing here. Okay, you will get it. But let me explain it again in brief. So we need the length of the destination string because we need to know from which index we need to begin appending from, right? So in this case, we have this. Let me remove this part. So we have something like this with the terminating null byte, right? So what is the length of this string? The length of this string is 3. We have 0, 1, 2, 3. Sorry, this is the index. So the length is 3. We have SAM, right? So the length is 3. So from which index do we need to begin appending the content of S2? From index 3. So it means that the length of the string, of the destination string, is equals to the index in which we need to begin appending to. That's why we need to find the length of dest. Okay, please refer to the previous video if you've not gone through it. So this is what we need to do, and we all know why we add the I here, because we need to find the I so that if we move to the next iteration, that is if we are concatenating O here, it will create what? Or it will append O here at the next index. So this is just J will be appended here. This is index 0, 1, 2, 3, 4, right? So this is what will happen. So SRC will now be incremented. So for the first iteration, this part will be executed and SRC will be incremented. So this condition will be checked again. So it will check what is now in SRC. Since we've incremented SRC in the first call, like I said, it is G, right? Asterisk SRC. It is targeting what? The exact character in SRC, which is G. So if you say SRC plus plus, it will move to the next index, which is this O now. So it will check, is it equals to terminating null byte? No. So if you say SRC plus plus again, it will now target this one. If you say SRC plus plus, it will target this. Do you get it? It's just moving from one character to the other. So we can do something like this. So here, we only have the what? The characters appended. How many of them? N of them, right? So when you look at this, when we append J and O, assuming we're appending 2 characters, if we append J and O, definitely we need to add what? A terminating null byte at the end. isn't it? So we need to make the provision for that here. So all I'm going to do here is I'll just say what? So I just say dest. Here I'm going to use what? Len, which is the len of the destination string, right? So I just say len and I'll just say plus I. So why am I saying dest len plus I? I'm still targeting the last element here. Do you get it? I'm still targeting the last element in what? In dest here. You all know that the last element is O. Considering this example here, the last element is O, right? So the last element is O. So what do we need to do here? When you look at this, I is included in my index here. And one of the conditions that will exit us from this loop is if I is equals to N or greater, isn't it? So this len plus I here is going to target the next index for me. So I will just add what? A /O. So in this case, I'm storing what? A terminating number at the end of the what? Concatenated string. Okay, this is just what I did here. Just adding a terminating number at the end of the concatenated string. So at the end, we need to say what? Return. What are we returning? We need to return dest, right? It says return a pointer to the resulting dest string. So return dest. That's also what the question says. Okay, so now let's run Betty on this. Betty 1. Okay, no description for member N. All right, so let's see. Okay, yeah, I've not described N. So here, I'll just say at N. At N, let me just say number of bytes to concatenate, right? To concatenate. All right, so let's save and let's run Betty again. All right, so let's create the test file now. Betty is happy. Copy. This is vi1 main.c. main.c. So pastes. All right. So hash I. All right. So let's copy the compilation command and let's compile. Pastes. Okay. Said okay. I need to include the stdio.h. So let me just do that in my main.h file. So vi main, because I'm using strlen without including the standard library, hash include stdio.h. No, I think it's not stdio. Is it stdio? I think it's string len. Let's see again. Yeah, it's not stdio actually. It's string.h. String. Yeah, I think this is responsible for that function. Yeah, so it has been compiled. So let's run it. Whoa, so as you can see, definitely something is missing somewhere. We are not getting the exact output. So let's open the file again, vi1, and let's make the correction here. All right. Okay, sorry, what I need to do here is I need to do something like this. Sorry. Here, I'm not supposed to do this. I'm supposed to say asterisk src here. Yeah, so it's going to copy asterisk src because we are using asterisk src here. So it's checking for asterisk src. So it will check. Okay, whatever is in asterisk src at that position, it is going to append it here. I've already explained how to use the asterisk src, right? The first call to asterisk src is the first character of the string. The next, when you say src plus plus, it will move to the next one. Plus plus moves to the next one. That's how it goes, right? So let's compile again. I think this should be the error. So let's run it. Asterisk 1. Yeah, so as you can see, we are getting the exact output here. So this, we are concatenating the string here. Okay, we are concatenating string. But how many string are we concatenating? N number of string. Okay, so this is simply how you can concatenate n number of strings. So here, as you can see, you specify the number of bytes in which you want to concatenate. Do you get it? You need to specify the number of bytes you want to concatenate. So don't forget to add, commit, and push to your GitHub, and then you can run your checks. So this project here says we should write a function that copies a string. So when you look at the prototype here, it takes in 3 parameters: test, source, and what, and n here. Your function should work exactly like strncpy. So you can just say man strncpy. Here you can read all the information about it, but I'll just explain in my own understanding here. So strncpy is a function that copies string from source to what? To dest. But it is not going to copy everything from source to dest. Instead, it is going to copy n characters from source to dest. So it means that if you pass 2 as the value of n, it is only going to copy 2 characters from source and what? And paste it at dest. If you pass in 10 as n, so it's going to copy 10 characters from source and paste it to dest. That's just what the function should do. Okay, so now let's copy our test file. Sorry, let's copy our file name, and let's open it. So paste. So I already have my Betty documentation here. So the next thing we need to do is begin writing our function here. All right, so we are copying what? We are copying what is in source to what? To dest, right? And how many characters are we copying? N bytes. So it means that we need to loop over src from 0 to what? To less than n, isn't it? And also we need 2 conditions to consider here, because we are looping where we need to make sure that our I did not exceed n, and we need to ensure that our src, right? We need to ensure that our src is not equals to the terminating null byte. So I just say int I here, right? I'm going to use this for the loop. I will say for I equals to 0, then one of the conditions is I has to be less than n. Since I'm starting from 0, I'm copying n byte, right? So the next thing is what? And also, right? And also src index I as well should not be equals to what? The terminating null byte. So these are the conditions I need to consider when looping over src, isn't it? And then I will say I++. So here inside the loop, I just need to do what? The copying. So I'm copying what? Source to dest, isn't it? So I will say src, whatever is in index I of source, that is what I want to copy to what? To dest here. So I'll just say dest index I. So let me explain this. Let me open my paint. So assuming you have the string you want to copy, which is the source, the source string, let's say is equals to, let's say, mom, for instance, right? So you want to copy whatever is here to what? To a destination string, isn't it? You want to copy it to a dest string. So it means that this is index 0, 1, 2, and 3, right? So whatever is in index 0 of source is what you want to copy to index 0 of dest, isn't it? So this is my index 0, so I'm expected to have m here. My index 1 of dest, I'm expected to have u here, since I'm copying everything of source to dest. My index 2, I'm supposed to have this m here, isn't it? I'm copying everything, right? I'm copying everything here. So the terminating null byte is not included during the copy, but we are going to add it at the end. Okay, so here, that's why I did something like this. So this is just saying that for each I, if I is 0, so copy the content of index 0 of source and place it in index 0 of dest. That is just what I explained here. Index 0 of source should be index 0 of dest. Index 1 of source should be index 1 of dest. Index 2 of source should be index 2 of dest. That's just what I just did here. Okay, so now we are done with this loop. So the next thing we need to do is we need to add what? We need to add a terminating null byte at the end. So I'm going to need a loop here, and this loop will fill the remaining position in dest with null characters until I reaches what? I reaches n. So this is just to ensure that if the source string is shorter than n, then the remaining characters in dest are properly terminated. That's just why I'm going to create this loop. So I just say while, I'm going to use while loop in this case. So I just say I less than n here. And then what? Inside the loop, I will just say, since I'm adding a terminating null byte, so I just say at the end of the dest len I, I'll just add what? A terminating null byte here. Terminating null byte, and then what? Again, I need to say I++ here. So I'll just say I++. So this is going to make sure that the remaining character in dest are properly terminated. Okay, so what's the next thing we need to do? We just need to return our function. So I'll just say return. What am I returning? I'm returning dest in this case, right? It is the variable that is holding what? The result of the copied string. So now let's run Betty on this. Betty to no description found for parameter n. Okay, I kept missing that. So let me do it again here. So this is at n. So number of bytes, I'm just number of bytes to copy, right? To copy. Yeah, so I think it's okay now. So let's run Betty again. So Betty is fine. So let's create the test file to test if our function is working the way it's supposed to work. All right, so this is 2main.c. So vi 2main.c. all right, so paste. Okay, I need to add this, yeah, hash I here. All right, so let's copy the compilation command and let's see if we are going to get the same output as this. So paste. Yeah, so it has been compiled. So let's run the compiled file. Yeah, so as you can see, we got the exact same output here. Do you see that? We got the exact same output here. 002A up to this point here. We got exact same thing. So I believe this is clear. So as you can see, we've successfully copied n bytes of the memory of source to to dest. Isn't it? That's just what this is. So in this test file here, they just created a lot of helper functions to check for the code. Okay, these are just helper functions here. Okay, you can go through it and you understand what this is all about. Okay. All right, so let's move on to the next task. Don't forget to add, commit, and push to your GitHub repository. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to bit12learn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX Complete C programming course. So because I'm already logged in, that's why I'm seeing continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, small nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also, if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor. Because I've already registered, that's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. So this task here says we should write a function that compares two strings. Okay, so this is the function prototype. This is the first string and this is the second string. So your function should work exactly like strcmp. This strcmp is a standard library function that does the same thing as the function we are going to write here. It's going to compare two strings. So firstly, we need to understand something. Let me man the strcmp down, strcmp. So let's just look at this. Let's just look at the description. It says the strcmp function compares the two strings s1 and s2. As you can see, s1 and s2, right? It returns an integer less than, equal to, or greater than 0. Take note, less than, equal to, or greater than 0. If s1 is found, respectively, to be less than s2. If s1 is less than s2, it's going to return what? It returns an integer less than 0, right? If s1 is less than, right? If s1 is less than s2, it is going to return what? An integer less than 0. It's going to return negative, right? Also, if s1 is equal to s2, it is going to return what? 0. That's just what this does. So what I'm trying to say is that if this s1 here, right, is greater than s2, the function is going to return what? Plus. You are going to get a number which is positive. The return value is going to be a positive number. Okay, if s1 is equals to S2 here, you are going to get 0. It is going to return a 0. Do you get it? If S1 here is less than S2, the function is going to return negative. Do you get it? So let's see how to do this here. So if I have, let me explain the concept here. Assuming I want to compare these values here. Let's say I have, what should I do? Let's say I have this set of string. Let's say car, asterisk S1. Let's say I have H, right? Hello, for instance. And here I also have another car, asterisk my S2. Let's say this hold world here, right? This is world. So what it is going to do is this. That's when the function is called. It's going to compare this with this, right? So it's going to check H and W. The moment it finds out that this is not the same, the first characters are not the same, then it knows that the remaining characters are not the same also. It knows that these strings are not the same, because from the first iteration they've realized that the first characters is not the same, right? So how can we be able to get the return values of this? So let's open the ASCII sheet here. So look at this. What is the ASCII sheet of H? ASCII code of H. So let's look at the ASCII code of H. Where is ASCII code? Where is H? Capital H in this case. The ASCII code of capital H is what? Is 72, right? So I'm going to write 72 here for capital H, isn't it? So let's look at that of capital case W. So that of capital case W is what? Is 87, right? So I'll just say minus 87. So when you look at this, S1 is 72 and S2 is 87, isn't it? So which one is less? S1 is less than S2, isn't it? S1 is less than S2 because S1 is 72 and S2 is what? 87. I'm talking about the first characters here. So it means that if you subtract 87 plus 70 from 72, what are you going to get? You are going to get a negative number, definitely, because 87 is what? Is larger, isn't it? If you are trying to subtract a larger number from a smaller number, you get negative. So this will give us what? A negative 15. So that is why in the description of the function strcmp, it says that we are going to get a value which is less than 0 if S1 is less than S2. And as you can see here, minus 15 is less than S2. Sorry, it's less than 0 because it contains a minus. That's just what the function says. So now considering we have, let's say here, I have, instead of capital H, let's say I have small h here, small letter h. Instead of capital H, I'm going to use small letter h here. So let me delete all this part. Yeah, all this. So here, I'm going to use small letter h. So let's check the ASCII code of small letter h. So what is the ASCII code of small letter h? Where is it? It's 104, right? So I'm going to have 104 here. Then minus, what is that of W? Capital case W, we've just checked that, 87, right? So I will say 87. So 104 minus 87. So if you subtract 104 from, sorry, if you subtract 87 from 104, you are going to get what? A positive 17. So as you can see, in this case, we are getting a value greater than 0. So that's why the function says in the description of strcmp, if your S1 is greater than your S2, then you are going to get a value which is greater than 0. As you can see, we got 17 here. Do you get it? So assuming here we have another h, another small h here. If we have another small h here, we know that this is definitely going to be what? 104 as well, right? 104, 104. Let me do this. Let me just clean it. So we are going to have what? 104, 104. So 104 minus 104 is 0. So that's why it says if S1 and S2 is equal, it is going to return 0. So I'm just trying to justify the description they made, okay? Of if S1 is less than S2, you get what? A negative value. If S1 is equals to S2, it returns 0. If S1 is greater than S2, it returns positive. That's just, this is just an explanation of what that description means, okay? So here, let's begin writing the code here. So let me open the file. So vi this. I've already begun documenting, or I've already documented Betty. So the next thing I need to do is let's begin writing the code. So what's the first thing we need to do here? The first thing we need to do here is we need to loop. right? We need to loop over S1 and S2 because we are comparing S1 and S2. Just look at this. We need to compare this one. We need to loop over S1 and check for the first character of S1, also that of the first character of S2. Move to the next character of S1, compare with the next character of S2. So we are going to loop over these two, these two S1 and S2 at the same time, right? We are going to loop over them at the same time. So here I will just say int I need to declare this to loop. So I'll just say for, I'm all starting from their index 0, right? So I equals to 0, right? So what should be the condition? The condition is, like I said, I'm looping over both S1 and S2, right? So S1I not equals to the terminating null byte, right? Or S2, index I not equals to the terminating null byte. So here, I'm looping over S1 and S2. Do you get it? I'm looping over S1 and S2. As you can see, I've set a condition for both of this here, right? So I just say I plus plus. So it means that the condition will keep running as far as the null byte of this is not reached or the null byte of this is not reached, right? So here, what do we need to do here? So if you look at what we just did here, if S1 is equals to S2, what do we need to do? I just explained that if S1 is exactly equals to S2, we are just going to return 0, right? So we have less work to do in this case. The place we need to do the work is if S1 is not equals to S2. Right? So let me set a condition for that. That's where the work is if S1 is not equals to S2. If S1 is equals to S2, I can just say return 0. That's all. So the work is when S1 is not equals to S2. Right? So I will just set the condition here. I will just say if S1, right? If S1 at that index I, at that particular index, is not equals to S2 at that particular ith index, then this is when we need to do something. Isn't it? This is where we need to do the work. If S1 is not equals to S2. So if S1 is not equals to S2, there are two conditions to check for. It's either S1 is greater than S2 or S1 is less than S2. I've explained this as well. If S1 is less than S2, we said we are going to get a negative value. Right? If S1 is greater than S2, we are going to get a positive value. So we have two conditions to consider if S1 is not equals to S2. That is S1 greater than S2 or S1 less than S2. Right? So I need to set a condition for that as well. So considering the first case, which is S1, let me just say S1 index I, if it is what? Less than S2 index I. I'm considering that of the less than. You can consider that of the greater than as well from the beginning. So if I have this, I need to check now. What should I do? Don't forget, I just explained that here. All you need to do is what? Is minus S2 from S1, right? That's all you need to do. You just need to say S2 minus S1. For both cases, that's what you need to do. If S1 is greater than S2, that's what you need to do. If S2 is greater than S1, that's still what you need to do. We need to do S2 minus S1. So here I will just say return. That's what I'm returning. So I just say return S S2, right? Index I, isn't it? Minus what? Or I'm not supposed to say S2, I'm supposed to say S1. Right? S1 index I minus S2 index I. Do you get it? That is exactly what I explained here. Okay, whatever is at that index that is not equals to S2I and it is less than this, then subtract S2 from it. Do you get it? That's also what the function says, the question says. So the next thing is what? What if S1 is greater than S2? So I need to say else if S2 here, in this case, index I, is what? Is less than S1. So you can say S2 less than S1, or you can say S1 greater than S2. Do you get it? So here we considered S1 less than S2. Here we are considering S2 less than S1. So what will happen in this case if this condition is true? We are still going to return the same thing. So we are just going to say return S1 index I, right, minus S2 index I. That's all we need to return here. Do you get it? So after all this thing, what do we need to do? We just say return what? We are just going to return 0 here. That is if what? If the S1 and S2 are matched. If they are matched, then it is just going to return this. If they are not matched, then it will execute this part here. It will check is S1 greater less than S2? If it is less than S2, then it will return this. The function will automatically return this. If S1 is less than S2, it will return this. And I've explained this already here. We just need to subtract the ASCII values. Okay, so let's test Betty. So Betty 3, yeah, so let's create our test file. So copy this, so vi 3 main.c, so paste. All right, so here I need to say hash I. All right, so let's compile this. Let's copy compilation command, so paste. Yeah, so it has been compiled. So let's run the compiled file. So as you can see, we got minus 15, 15, and 0. Why? Because here the function is being called. When you look at this, hello was passed to the function and world was passed as what? S2, right? S1 is hello and S2 is world. So it means hello world was passed to the function. So it's going to compare this H and W, right? H and W. And if you can remember, this is the first case we considered, H and W on our example here. And we got a negative 15. We use the ASCII values, right? Let's check. The ASCII value of H, capital H, is 72. That of W is 87. So 72 minus 87 is going to give you a negative 15, right? That's why we are having what? A negative 15 here. Did you see that? So in this case here, S2 was passed first before S1. So it means that what? H will be at the top and W will be at the top and H will be at the bottom. So this is going to be W minus H. So what is the ASCII value of W? ASCII value of W is 87 and that of H is what? 72. So it's going to be 87 minus 72. So in this case, we are going to get a positive number. That's why we're having a positive 15 here. And here, S1 and S1 is passed. So it's still hello and hello. And as you can see, we are getting 0 here. So this is simply how to do this. Okay, so don't forget to add, commit, and push to a GitHub, and then you can run your checks. So I think we're going to stop in this example. In the next video, we are going to continue from task 4 of this project. So thank you very much till we meet in our next video.